Our next research question is about regenerative braking, how it works, and some of its future applications. Regenerative braking system is a form of kinetic energy recovery system that converts the kinetic energy of the moving object to the potential energy that slows down the vehicle and improves its fuel efficiency. The regenerative braking system is also known as a kinetic energy recovery system. These systems use a variety of energy conversion techniques such as springs, flywheels, electromagnetics, and hydraulics. Some of the future applications of regenerative braking is that it's used in hybrid as well as electric cars. The regenerative brakes will work in hybrid as well as electric cars. Currently, both hybrid as well as electric cars use an electric powertrain to provide power, making the regenerative brake simple and effective. The gearbox of these automobiles is set up such that when the driver applies the brake, the electric motor reverses and gives resistance to the wheels instead of the power. The resistance applied to the wheel is transferred into the electric motor that recharges the batteries. How does it work? To understand how regenerative braking works, one must first understand how the traditional brake system works. So when one presses down on the brake pedal, friction is created between the discs and brake pads. As a result of friction, the kinetic energy is created, which is then dissipated as heat into the surrounding. This terms some of the kinetic energy that would be converted to heat rather than electricity. Also, during acceleration, the engine drives the wheels, whereas during deceleration, the wheels drive the motors. This two-way energy transfer enables the motor to function as a generator, resisting the wheel motion and producing power to recharge the vehicle's battery. One can say that there are two conditions when this type of braking occurs. First, the driver applies the brake pedal. Second, driver releases the acceleration pedal. These circumstances generate electricity to recharge the battery. This regenerative effect may be seen on the vehicle's charging gauge as energy goes from the wheels to the battery. So now we know the amount of electricity produced by the system is proportional to the amount of braking force applied. From here, we can say that higher the electrical current, the greater is the braking force. Disadvantages: even the regenerative braking system has its own set of disadvantages, as any other system will have. Firstly, it loses its effectiveness at low speeds, which is very obvious. Regenerative braking cannot catch much energy and give it back to the battery in slow-moving stop and go traffic, decreasing system benefits for many commuters during the rush hour. It can alter the sensation and modulation of the brake pedal. These brakes can be insensitive or difficult to modulate for smooth, clean braking and stop depending on the vehicle and design. It also might not have the same stopping power as conventional brakes, requiring some drivers to hit the pedal hard. Drivers should be aware of this and adjust their driving style.